The great expert on swept wings in pre-war was Professor Buseman of the research establishment at Focke-Wulf.
1944. A four-engined powerhouse flies through the clear skies over Kansas. The Boeing B-29 is ready to join the war after a lengthy and troubled development that began in late 1939. With 1250 caliber Browning machine guns and a standard loadout of 20,000 pounds of bombs, it truly lives up to its nickname, the Superfortress. Designed as a high-altitude daytime bomber, it is intended to be used in the Pacific theater of the war. The finished planes are flown from the Boeing plant in Wichita, Kansas, to the eastern tip of North America in Newfoundland, across the Atlantic Ocean to Morocco, to Iran in the Middle East, and finally to India, where they will be stationed for several months. From here, they can be sent to China, where they will be within striking distance of the home islands of Japan, which have been free from direct attacks since the Doolittle Raid of 1942. But one of these bombers has a different fate. Its mission is not one of destruction, but of deception. It is flown from Kansas to Newfoundland and across the Atlantic. As its fellow B-29s are striking targets in Asia, first Bangkok's railroad shops, then the Imperial Iron and Steel Works of Japan, this one is headed for England. Instead of arriving under the cover of night, it arrives in broad daylight at RAF Bovington, northwest of London. Landing before a crowd of onlookers, it is driven up and down the runway, a show of the Allies' latest marvel of the air. And the crowds are impressed indeed. The B-29 is one of the largest aircraft ever built, at a length of 99 feet and a wingspan of 141 feet. But one of these onlookers isn't there to appreciate America's latest technological achievement. Returning home, the man is careful to conceal what he is about to do. Retrieving a straight key transmitter from a hidden location, he prepares to send a signal across the channel to Europe. There, an operator receives the message and decodes the warning about this new threat, passing the valuable information on to the headquarters of the German Air Ministry. And this is exactly the scenario the Allies have been counting on. With good knowledge of where spies in England are located, it is known that this information will be sent on to their enemy. With the war dramatically turning against them, the notion of even heavier bombing is a frightening prospect for Germany. The US Air Force's Big Week offensive in late February of 1944 had the Americans flying heavily escorted bombing missions against airframe manufacturing and assembly plants around Germany. The results have been devastating, with the Luftwaffe losing close to 100 of their fighter pilots. Panic is rising all around, and this information is making matters much worse. The Americans have leaked enough information about the new bomber for the Germans to know just how much of a threat they are facing. If the B-29 is to be used in Europe, Germany will need to form a defensive strategy to shoot them down, and this poses a problem. The B-29, with its pressurized cabin, can fly at an incredible altitude of 40,000 feet. Though some of the German army's more powerful artillery can fire to that height, the bombers will be almost impossible to hit. And as Germany has not yet developed proximity fuses, it will prove a challenge for their defences. If B-29s do appear in the skies over Germany, they need to be brought down by other methods. With the recent development of the turbojet engine, Germany now has fighter aircraft that can fly at incredible speeds. But will that be enough to combat the threat of the B-29? The Messerschmitt Me-262 is Germany's latest jet aircraft. Powered by two Junkers Jumo 004 engines, it is a deadly adversary for Allied aircraft.
Right, now the Me-262 was, in my opinion, I've stated this many times, the most formidable aircraft of World War II. When you consider that at the end of the war, the top Allied fighter was the Spitfire Mark 14 with a top speed of 446 miles an hour. When we tested the Messerschmitt 262, it had a top speed of 568 miles an hour. This was a quantum jump in performance, and it meant the 262 was virtually inviolate.
Originally straight-winged, the production version of the 262 has wings swept at an angle of 18.5 degrees. This is done to adjust the aircraft's centre of gravity when the engine proved to be heavier than originally expected.
It had one shortcoming, but then I would say two shortcomings, but all the early jets did in our country, in America and in Germany. Firstly, the engines were very sensitive. They were slow to accelerate to throttle movement, and you had to handle them very carefully to avoid flaming them out. Secondly, we hadn't thought, or the designers hadn't thought, of how to slow down these incredibly fast airplanes, and no air brakes were fitted. And this made life very difficult, for example, for landing.
The 262's standard tactic against bomber formations approaching from a higher altitude and then diving down to their level and opening fire will not be effective against this new enemy. The 262 only holds enough fuel for approximately 1 hour in the air. It takes close to 15 minutes for the aircraft to reach its maximum altitude, not including the time it needs to locate its targets, which eats up plenty of fuel. Experiments are undertaken to see if this problem can be overcome. In one case, a rocket engine is added to a 262 to provide a boost during climbs. Another idea proposed to increase the plane's rate of climb is to mount ramjets on its wings. And while the ramjets will provide more thrust, their added weight would slow the aircraft down in level flight and deplete even more fuel. Tweaking the Me-262 is not the answer the Air Ministry is looking for. However, Germany also has a light fighter in development, the Heinkel 162. As raw materials and qualified pilots are becoming scarce, a cheap-to-produce and easy-to-replace plane is appealing. Officially named Volksjäger or People's Fighter, it is also known as the Salamander. Constructed primarily of wood, it is roughly half the weight of other fighters and houses a BMW 003 engine in a nacelle mounted on top of the fuselage.
The Heinkel 162 was certainly an intriguing idea. It was a well-designed aircraft. The catch is the Germans were running out of time. They were planning to use teenagers out of the Hitler Youth or out of the National Socialist Flying Corps, which at least had some basic training on gliders. Train all these youngsters on gliders and put them on single-seat jet fighters, because there was no two-seat version of this thing, and hope for the best. Keeping in mind you had to produce these things. Again, you need the resources, you need the fuel, you need the workers. It was not an aircraft for the uninitiated. It was a jet aircraft, after all, a very high-performance machine. So put inexperienced pilots in a fairly hot machine with lots of Allied aircraft buzzing all around was not a good idea.
And despite its lightweight and high speed, the Salamander has even less endurance in the air than the Me-262, and so won't be able to combat the B-29 effectively. Several technical hurdles still need to be overcome before the next generation of German jet aircraft can take to the sky. In England, Frank Whittle's centrifugal jet engine has proved to be very reliable, able to endure over 100 hours of flying time before requiring repairs. But that reliability comes at the cost of speed. The Junkers and BMW axial flow engines, while much faster than anything the Allies have, are complicated to produce and last no longer than 12 hours in the air before a full retrofit is needed, and a total of only 25 hours until they need to be replaced. But new engine developments are on the way for Germany, courtesy of Heinkel He, the HES 011 turbojet engine. Featuring a unique combination of the axial and centrifugal compressors, it promises to be easier to produce and more reliable than the other German engines.
All German project development in the latter months of the war were all based around the HES 011 engines, but then there were many other manufacturers, engine manufacturers, who were actually developing even more powerful engines, and some of today modern day airliner engines today can actually be traced back to some of those ideas.
After the First World War, Germany had been forbidden from developing military aircraft technology, but they were not stopped from the development of all technologies related to flight. So while aircraft makers in the rest of the world were working to improve the performance of powered aircraft, the Germans were designing gliders, with many engineers taking a keen interest in aerodynamics and how to use the natural forces in the atmosphere to fly further and faster. The development of the modern wind tunnel by Ludwig Prandtl opened new horizons for the testing of how various shapes dealt with airflow. As war loomed once more, there arose a need for faster aircraft, and the proliferation of wind tunnels across Germany would help in the testing of new designs. So the development of the high-speed jet engine is identifying problems that had only been seen in wind tunnels before, that straight wings lose stability just above and below the speed of sound, in what is known as the transonic region. But in theory, a swept wing will lessen the drag caused by the formation of shock waves as airflow wraps around the wings.
The great expert on swept wings in pre-war was Professor Busemann of the research establishment at Focke-Wulf. And he gave an open forum lecture in Rome in 1935. And he put forward that sweeping the wings back doesn't mean you can go supersonic. What it does do is it smooths the transition from transonic flight to supersonic flight by reducing the compressibility effects. So it's a great aid on the way to supersonic flight, but it is not the key to supersonic flight.
Despite the fact that many leading aircraft experts of the day had attended the Volta conference in Rome and seen Adolf Busemann's presentation on swept wings, it was considered little more than an academic curiosity. As the airspeed record of 1935 had only been 440 miles per hour, the notion of supersonic flight seemed a very long way off. By the time World War II breaks out, Busemann's theories are all but forgotten. He conducts experimental wind tunnel tests of his theories, and by 1942 has amassed a considerable amount of technical data. Now, as planes on all sides are becoming faster and reaching the transonic region, they are witnessing the dangers that compressibility effects have on aircraft. Buseman's theories can finally come to the fore. Knowing that they have the technological advancements required to combat the B-29, Germany now needs an aircraft to house them. On July the 15th, 1944, just over a month after the D-Day landings, the Luftwaffe decides to halt all production of bombers and multi-role aircraft. Defense is now the name of the game. Calls go out to the top German aircraft manufacturers for an emergency fighter, a jet aircraft that can take on the threat posed by new Allied fighters and the American Superfortress. At Messerschmitt, preliminary plans for a new fighter are drawn up. This aircraft, designated P-1101, will have a short, wide fuselage and tricycle landing gears. Willy Messerschmitt is curious about the benefit of swept wings, having researched the topic since 1940. Wind tunnel tests on models with various wing and fuselage profiles are conducted, and the differing results that each swept wing profile returns is intriguing. As many components have already been built, it is decided that the best way to get accurate test results is to build a prototype aircraft. Without the official backing of the German Air Ministry, Messerschmitt goes ahead and begins construction. It is given a mechanism that allows the wing sweep to be adjusted on the ground from 30 to 40 to 45 degrees. Other aircraft firms also submit designs for an emergency fighter. At Focke-Wulf, head designer Kurt Tank believes his team has some advantages over the competition. His FW-190 is already a workhorse for the Luftwaffe, with over 20,000 produced.
Kurt Tank was a brilliant designer, but he was also his company's assistant chief test pilot. And he had this huge advantage of knowing how to fly the airplane, and even was prepared to fly it in combat. When he flew from Bremen, whenever he was up, he would look around to see if there was any chance of getting a combat, and he was a remarkable man. He just thirsted for knowledge.
In March of 1943, one of Tank's team at Focke-Wulf had begun work on a series of design studies for a single-seat jet-engined aircraft. The man behind the designs is engineer Hans Multop. Multop had studied under Ludwig Prandtl at the University of Göttingen, where he wrote a thesis on the lift theory of wings. In 1938, Kurt Tank brought him to Focke-Wulf to work as his assistant in the Department of Developmental Aerodynamics, and by 1943, Multop had gone on to become a chief designer. Operating under the theory that the longer the distance the air must travel before it reaches the engine, the less power it will have, the Flitzer, or Madcap, is designed around a very short fuselage, with its jet intakes located at the wing roots. Its wings have a leading-edge sweep of 32 degrees. A twin boom holds the tailplane above and out of the way of the exhaust from its single HES-011 engine. The jet propulsion is to be supplemented with a Walters liquid propellant rocket engine, but it is removed from the final designs. Curiously, the Flitzer's design is very similar to that of the Vampire, another aircraft being developed in England around the same time. It is the second jet aircraft to be commissioned by the RAF. Both the Flitzer and the Vampire are single jet-engined aircraft with a short fuselage and twin booms supporting the tailplane. This coincidence comes about not through espionage, but simply the common logic of creating a jet fighter with a single engine for better fuel economy, and to provide centerline thrust. The Flitzer is well along in development, with a full-size mock-up and some prototype sub-assemblies completed. But despite the progress, the project is abandoned, because the plane's performance is expected to be no better than that of the Me-262. But when the emergency fighter program is announced, Hans Multop already has all the experience and knowledge gained from developing the Flitzer to work from. His next design, the TA-183 Huckebein, will be the culmination of aerodynamic research that his team began in 1942. And one of the major new steps implemented will be the use of fully swept wings. Taking its name from a mischievous cartoon raven, the Huckebein has wings mounted in the middle of its short fuselage and swept back at 40 degrees. It has a pressurized cockpit with a bubble canopy providing excellent all-round vision. The Huckebein's fin is very long and tall, putting the tailplane above the flow of the air as it wraps around the wings, lessening the amount of turbulence. The first design uses a T-tail sitting at the end of a long vertical stabilizer swept back at an angle of 60 degrees. As tests progress, the T-tail gives way to a V-shape that is bent slightly upwards. It is intended that the plane will use the HES-011 jet engine. However, prototypes will use the same Junkers UMO 004 engine found in the ME-262. And like the Flitzer before it, early studies for the aircraft call for it to be equipped with a rocket engine, with enough fuel located in underwing drop tanks for a 200-second rocket burn. But again, the rocket engine is removed before designs move forward. A single jet engine will propel the Huckebein, giving it more range and better fuel economy than the two-engined ME-262. Expected to be able to fly at speeds of 1,000 kilometers per hour and up to an altitude of 45,000 feet, the Huckebein will swoop down from above and blast the bombers with its 4 30mm cannons. But will cannons alone be enough? The B-29's revolutionary central fire control system allows the gunners to direct 4 remote-controlled turrets, each armed with 2 50-caliber machine guns through the use of analog computers. Highly advanced for their time, the General Electric designed computers correct for airspeed, target speed, and other factors that can hinder the gunner's accuracy. These improvements make it dangerous for fighters to get too close to the B-29. To combat this, Germany needs an advanced weapon of their own. At the Ruhrstahl Company in Düsseldorf, Dr. Max Kramer is working on just such a weapon. His goal is to build a missile with enough range to allow it to be fired from well out of reach of the bomber's guns, while being guided with enough accuracy to hit its intended target.
During the Second World War, there was a lot of work being done on surface-to-air anti-aircraft missiles, guided weapons of various types. There was a bewildering variety of types that the Germans worked on. Not all of them very practical, mind you, but a lot of variety. They were also involved in early designs of air-to-air missiles. I know of one, which doesn't mean there were not more than one. I know of one, the X-4. Fairly small weapon, again, air-to-air. You wanted to use something that was tiny, just by Second World War standards, something you could almost hold in your arms. It is the ancestor of the modern air-to-air missile.
The X-4 is guided by signals sent via thin wires that run back to its guidance mechanism on the aircraft. As the missile flies, the wire is reeled out behind it. A small joystick in the plane's cockpit allows the pilot to guide the direction of the missile. That, as well as having enough rocket power to fly for 3.5 miles, makes it the ideal weapon for staying out of range of the B-29's guns. But because it is so difficult for the pilot to judge the distance to the target aircraft from so far back, the missile is armed with a newly developed acoustic-based proximity fuse, known as the Kranich. As the X-4 project is well known to aircraft engineers, the Huckebein is designed with the missile specifications and requirements in mind, possibly making it the first instance of a complete weapons system. On February the 28th, 1945, the Luftwaffe High Command examines the emergency fighter proposals and selects a design by Junkers to be developed and produced. The Huckebein comes in second place. But before long it is decided that the Huckebein is a better design, and Kurt Tank is told to plan for full production. Flight tests are scheduled for May of 1945 and 16 prototypes are to be built. Then, on April the 8th, British troops capture the Focke-Wulf facilities, ending any chance that the TA-183 Huckebein will see the prototype stage. The HES 011 engine, still delayed, never makes it into mass production. By the end of the war, only 19 engines have been built. In the months following the war, agents from Allied countries scour Europe for designs and ideas that can be used by their country's aircraft industry.
There were so many projects produced and so many projects found at various aircraft manufacturers that the Allies really didn't know what was actually worth pursuing and what wasn't. And a lot of the Allied aircraft engineers thought that some of this stuff was pie in the sky anyway, and thought that, well, you know, we know what we're doing and we're going to do it our way, which actually was not a very good idea, because the Germans were a long way advanced on their high-speed development of bombers and aeroplanes, unconventional designs.
Adolf Busemann is visited by a group of American scientists at his lab in Braunschweig, some of whom had attended the Volta Conference in 1935, but had overlooked his research then. It is only now that the Western Allies begin to see the potential of swept wings. The B-47 Stratojet, in development as a straight-winged bomber, is given swept wings when Boeing's chief aerodynamicist relays the information back to the United States. At North American Aviation, the wings of FJ Fury fighter jet receive a 35-degree sweep before going into production as the F-86 Sabre. After the war, Hans Multop moves to the United States as part of Operation Paperclip, under which the US intelligence and military extract scientists from Nazi Germany. Working for the Martin Company, his knowledge of swept-wing designs contributes to later versions of the F-84 and the F-86 Sabre, as well as the experimental X-24 lifting bodyplane. Kurt Tank is offered a job at the Aerotechnical Institute in Cordoba, Argentina, by Juan Perón's government. The ideas behind the Huckebein lift off again as he gathers a team from the Focke-Wulf Design Bureau. As the HES 011 engine is no longer in development, it is replaced with one by Rolls-Royce, the Nien 2. The fuselage is widened to accommodate this larger centrifugal engine. The wings are mounted higher up on the fuselage as compared to the Huckebein. The new aircraft is named the Pulki II. Test flights begin on June the 16th, 1950. The plane reaches the incredible speed of 1,000 kilometers per hour. But as promising as that is, there are other problems. Pilots find the aircraft very difficult to handle, and 2 are killed during test flights. And those are not the only problems Kurt Tank faces. An economic crisis hits Argentina in 1953. The pricey Pulki II project is halted, temporarily at first, but in 1955 Juan Perón's government falls, dealing Tank's team another blow. Soon after, the availability of cheap F-86 Sabres makes the development of a homegrown fighter a needless luxury for Argentina. It is not only the Western Allies who benefit from the work of German aviation experts. In the dwindling days of the war, Soviet forces discover the Huckebein's plans and several prototypes, which are transported back to Russia. Because of this, it is often thought that the Huckebein may have inspired the fabled MiG-15, an aircraft that rivaled the Sabre. And although the MiG-15 and the Huckebein share a number of similarities, such as swept wings, a high rate of climb, an elongated tail fin, this theory has been discredited. The majority of Focke-Wulf's engineers were taken in by the Western Allies. However, as the Soviets had possession of the German Air Ministry, the central repository for all Germany's aviation ideas, they did have all the technical data and designs dealing with swept-wing aircraft, which would have provided them the proof that swept wings were a good avenue to follow. That single B-29 landing in England set in motion events that would be felt for years to come. While it did have the intended consequences of surprising the Germans and forcing them to pour their already thin resources into the development of another new aircraft, it also laid the groundwork for swept wings to be adopted earlier than had the need for an emergency fighter not been so dire. And while the implementation of sweep theory is a boon to aviation progress, it will come back to haunt the United States in the years to come, when the MiG-15 appears in the skies over Korea.